Hi, good morning to one and all. And my name is Anjaneyulu. I am working as assistant professor in EEE department, Sasi Engineering College and Technology. And I would tell about some important topics in signals and systems. And first of all, we know about the important topics in the signals and systems. And first of all, we discuss about the main definition of the signals and systems. Signal is a device. Signal means it is a physical time varying quantity and it carries information which intended to carry information. And the examples for these signals, that is the familiar example is human voice and the electrical current and voltage on the communication telecommunication wires. First of all, signal and another, that means noise signal. Noise signal is a signal but it carries unwanted information. That is, noise signal is a signal that is for the unwanted for the some others and it is wanted for the some peoples. And next one, the system is a device, and the system is a device which is working on the operation and signals. It depends on the characteristics of the signals. And the example of that means the system is a group of elements, or a group of elements are connected together and working based on the characteristics of the signals. And first of all, discuss about the classification of signals. Classification of signals, and the first one is unit step signal. And second one is unit impulse. Third one is unit ramp. And remaining will be parabolic. And another one is signum. Rectangular pulse, triangular, and some of the signals. In this, we discuss about the main important signals, that is the unit step and unit impulse. In this, first one, we will discuss about unit impulse or unit step. And in this, it can be represented in the two forms, that is continuous time and discrete time. And the difference between the continuous and discrete time: in the continuous, the signal is defined at every instant of time, that is the continuous time. And in discrete, it can be defined at particular intervals or only discrete time instants. That can be, to take an example, per step, unit step, that can be represented in continuous time. That is in step, unit step. Unit means the amplitude is constant at 1 only, 0, 1, 2, 3 and so on up to infinite. And in discrete form only the time is taken at only discrete intervals of time. The amplitude is constant at 1 and so on. This is the representation of continuous time signal that is in unit step, that can be represented in continuous time domain, and unit step that can be represented in discrete time. And first of all we can define how to define and how to represent unit step. Unit step that can be denoted by u of t, that is in continuous time, or u of n, that is in discrete time. And first of all we can be define u of t, that will be equal to 1, that is for t greater than or equal to 0, 0 for t less than 0. It can be defined as the unit step that is in continuous time, that can be represented in this is the continuous time unit step. The amplitude at 1 it constant up to infinite duration. And next unit step that is in discrete time, that can be represented as u of n, that can be defined as 1 for only the difference between continuous and discrete is the time function t. This can be represented in continuous time. The small n that can be represented in discrete time, 0 for n less than 0, n greater than or equal to 0, that can be represented as this is the unit step that can be represented in discrete time. And first we will discuss about, that means the main difference between continuous and discrete is in continuous time the value can be determined for decimal values, that means 0.2, 0.7, 1.2 and so on, that can be defined in the continuous time. In this discrete we cannot define decimal values, that means 0.2. In this discrete we cannot say or we cannot define only the discrete instants of time. That is the difference between the continuous and discrete. And we discuss about some important properties that can be in unit step. We will discuss about that means first one is u of t whole power n, that means u of n, or in discrete or in u of t, that is in continuous, or u of n is equal to u of n. And another one is u of t minus t naught power k, that is equal to u of t minus t naught. And one more property is E of at, that is equal to E of t. E of t. E of t. First one is, that means unit step that can be powered, that means square or cube or cube or square, that can be, that cannot affect, because the magnitude is 1. That means this is the E of n, E of t. Squaring means another signal, that means E of 1, 1. The amplitude is 1. This can be multiplied, that means E of n whole square. That means the same unit step is repeated. The same unit step is repeated. That's why this property is E of n, that means square or cube does not change the unit step function. The amplitude is 1. This is also 1. It multiplied with 1 and 1, this signal and this signal. So that's why the signal will be, the same signal will be come. That's why E of t power of n, E of n power of n, that will be equal to the E of t. And next one, shifting. That means the unit step will be shifted to the t naught value. That means t naught, that can be squared, means this can be modified. That means that can be shifted at t naught value. This can be multiplied with this, that means E of t minus t naught. That means E of t minus t naught. This can be multiplied with. So then the shifted version of unit step, it will be squared or cube, then it will does not change. That's why the initial, that means the shifted version of unit step will be repeated. Okay, and this is two properties are over. And another property, that means scaling. The scaling does not affect the unit step function. You can see unit step that can be defined for 0 to infinite, that is in constant value. So that's why 1 at 0 up to infinite. That means the unit step means the time scale will be divisible by a and infinite by a. So that's why the E of at will does not affect, that means the scaling will does not affect the unit step function. So that's why 0 to infinite, the scaling will does not affect. That means 0 divisible by a and infinite divisible by infinite is infinite. So that's why the scaling will does not affect the unit step function. And another one more signal, that is important signal, is the impulse signal. Unit impulse. Another one is unit impulse. Unit impulse. Unit impulse. It is denoted by del of t, and it is defined as del of t equal to 1 for t equal to 0, 0 for otherwise, that means t is not equal to 0. This can be represented as, it will be defined only at t equal to 0, the value of impulse is 1 only. The remaining values, that can be -1, -2, these are values are 0. Only at 0 the magnitude is 1, that means the amplitude is 1. This is impulse, and this can be represented, that is for discrete also, that is delta of n. The only change is t, in place of t we can take it as small n, that is 1 for n equal to 0, 0 for n is not equal to 0. That is same can be repeated, and at 0 the value will be 1. This is the discrete impulse that can be defined, and the pictorial representation that can be shown as this two. This is continuous time, this is discrete time, and in this some of important properties are there. We will discuss about this, will the properties in one by one. That is first one, integral minus infinite to infinite del of t dt equal to 1, and second one is delta of n minus k equal to del of n minus k equal to, that can be defined as 1 for n is equal to k, 0 for n is not equal to k. And next one, del of n equal to e of n minus e of n minus 1. And next one is f of t into del of t equal to f of t naught, f of t naught. That means e of n minus e of n minus 1, L of t equal to f of t naught, and the remaining also will be, I can represent it. After that I will explain in one by one. And fifth one is del of t minus t naught into f of t, that is equal to f of t naught and another one is del of kt, that means scaling, into, that is modulus of 1 by into del of t, and another one is del of t equal to del of minus t. We will discuss about one by one, and that is the area under unit impulse or unit step or unit ramp. The area under this is 1. The area under the unit impulse, unit step or unit ramp is 1. So that's why first property, that means integration minus infinite to infinite del of t into dt equal to 1, but no need to integrate about the minus infinite to infinite. So because the del of t that can be defined at only t equal to 0, that's why the del of t at t equal to 0, that means 1. that means minus infinite infinite, no need to integrate about, only at t equal to 0 we take it t equal to 0, that means del of t equal to 1. The area under unit impulse is 1. And next, del of n minus k, that means this is shifted version, that means this can be shifted to positive side, that means right side, and we will discuss. And we will discuss, that is del of n minus k, that means second one, n minus k that equal to 0, that means n equal to k. So that's why we will represent it as here del of n minus k that is equal to 1 for n equal to k, 0 for n is not equal to k. That can be, this is the shifted version. And next one, del of n is, that can be first one is over, one by one I will be explained clearly. That is second one is third one, del of n is equal to e of n minus e of n minus 1 minus e of n minus 1, that is e of n we know about, we know this, that means e of n, that is at unit step means 1, that is e of n and so on, that is the e of n. And another one is e of n minus 1, that means this is the shifted version, that means the starting at the 1 only, at 1, 0 it will not define, this is the shifted version. That's why this is the e of n minus 1, this can be time axis, this is the unit shape, shifted version of unit shape. And subtracted e of n minus 1 from this e of n. In this e of n at 0 the value is defined, in this at 0 the value is does not define, that's why e of n minus e of n minus 1, this one this cancel, this one and the remaining will be only at t equal to 0, that means del of n is equal to e of n minus e of n minus 1. This is the third property. And fourth property is, and the fourth property we will discuss. That means f of t into del of t equal to f of 0, that means del of t is, that can be represented as at 0 this can be value is 1, that is the del of t. And f of t we can take some of the signal, that can be we take as cos value, this is the f of t, this can be multiplied with del of t, and del of t is equal to 0, this can be defined as 1, and f of t that can be 0, f of t at t equal to 0 this value is 1, the remaining will be varying, but the multiplication only we take it as del of t into f of t, the combination will be, it will gives f of 0, remaining it will does not define, so that's why remaining part will be 0. This is fourth property is can be proved. And next another property, that means del of t minus t naught into f of t into f of t naught. You can take a same example, but del of t means that is shifted version at T naught equal to this value is 1, that is del of T minus T naught. And the another signal we take it as same signal or sine wave at T naught sum. This value also T naught, that can be defined as it. This is T naught. So that's why T naught at one impulse. So that's why this 2 can be multiplied. Then the resultant is f of T naught. That means in this f of t, this value T naught, in the same T naught, the value will be in this function. So that's why f of T naught. So this can be proved. And another property, that means scaling del of at equal to 1 by a del of t. That is the scaling a that can be divisible by. That means some a value is taken 2 or 1, that is del of 2t equal to 1 by 2 into del of t. That means del of t is equal to at 0, this can value is 1. Okay, that means we can prove that the scaling will affect the area of the impulse function or impulse signal. And next another one is del of t equal to del of minus t. That means this condition is a even signal condition. That is some signal x of t that can satisfy in place of t we can take minus t, then the original signal will gives the response, then it is a even signal. So that's why that can be even signal. The impulse is at 0, the value will be taken as 1. So that's why minus t we need to replace. So that's why del of t is even function or even signal. In the classification, some important, that means in this classification unit impulse and unit step signal are very important. So that's why we will discuss unit step and unit impulse. And another topic, that means another question, that is classification of systems. We can take we can explain about the classification of systems. Classification of systems topic. In this some more systems will be discussed. We will discuss, that is classification of systems. Already we discussed what about the definition of the system. System is a device. System is a device that can be intended to operate or to carry information or the input signal given, then it gives or transforms the signal to the output signal, then it is a system. In this classification, first one is lumped and distributed parameter systems. Lumped and distributed parameters systems. Second one is static and dynamic systems. Static and lumped and distributed parameter system. Second one is static and dynamic. Static and dynamic. Third one is causal and non-causal. Causal and non-causal. Fourth one is linear and non-linear. Linear and non-linear. Fifth one is time variant and time invariant. Time variant and time invariant. And another one is stable and unstable system. Stable and unstable systems. Stable and unstable system. And first one is lumped and distributed parameter system. That means in lumped parameter system is a system in which each component that can be lumped at one point in the space. In distributed all the functions of signals are distributed manner. That means in space as well as time. This is the lumped and distributed. Next, static and dynamic. Static means this is also called as memoryless. Dynamic also called as memory system. That means memoryless means it gives only before data will not maintain at the time of t that can be maintained. That means static, that can be defined as the static system. You can say that a system is said to be depends only on present values of the input, then it is called as static. And dynamic is it will depends on future and past values. That means future input values of the system. That means you can take as dynamic and static. You can take as examples. First one is static. That means x of t is equal to static. That means y of t equal to 2 into x of t. That means put t equal to 0. That means y of 0 equal to 2 into x of 0. That means the time values are same. So that's why the system it will depends on the present input values of the system. So that's why it is static. We can take it as another example. Y of t is equal to x square of t. This is also a static. Otherwise y of n is equal to x square of n. Otherwise y of n is equal to 2 into x of n. These are also static system examples. And the another one is dynamic. Dynamic system examples are it will depends on future or past. That means y of t equal to x of y of t is equal to x of t plus 1, or y of t is equal to x of t minus 1. This is put t is equal to 0, y of 0 is equal to x of t. 0 plus 1 means x of 1. That means the output is depends on the future values of the input. That's why this is dynamic system. This is also a, that is t equal to 1 means y of 0, that is x of minus 1. That means previous values, that means past values. So that's why this is also a dynamic system. These are the static and dynamic system examples. And next one is causal and non-causal. The causal will defined as a system is said to be causal if it satisfies or the output of the system. The causal next one is causal system. Causal and non-causal, causal and non-causal. Causal means it is the causal system is the system is said to be causal if it satisfies or if it depends on past and present values of the input. That means the system is depends on past and present values of the input. So that's why then it is called as the system is causal. Otherwise non-causal. That means non-causal means it will depends on future values also. Then it is called as non-causal. For example, x of y of t equal to is equal to x of t plus x of t minus 3. That means we put t is equal to 0. That means y of 0 equal to x of 0 plus x of t plus in place of 0, that means minus 3. That means minus 3 is the past value, 0 is the present value. So that's why the given system is causal. And we could take as in discrete also, y of n is equal to 2 into x of n plus x of n minus 3, or y of n is equal to x square of n plus x of n minus 4. These are also a causal systems. And another one, that means non-causal examples are that will depends on future inputs also. So that's why y of n equal to x of n plus x of n plus 1 plus x of n minus 2. This is non-causal system. It will depends on, this is present, this is the past value of input, this is future value of input, this is past value of input. So that's why future output also, the system it will depends on future outputs. So that's why this is non-causal system. In continuous can be represented by x square of t plus x of t minus 5. This is also a non-causal system. And next one is linear and non-linear system. Linear and non-linear system. Linear system, that is the system satisfies the superposition principle. That means individual transformation that will be equal to the total transformation. That is transformation of a into x1 of t plus b into x2 of t, that will be equal to transformation of a into x1 of t plus transformation of b into x2 of t. This is the superposition principle. Superposition principles, it combines the linearity and homogeneity. This is the summation, x1 of t plus x2 of t is the linearity condition, and the constants, the multiplication of constants by a and b, this is the homogeneity. If it satisfies this condition, if you take a system, this condition will satisfy, then it is called as linear system. Otherwise this condition is not satisfies, then the system is nonlinear system. We take as just one example for this can be explained. So we can take it as y of t equal to 2 into x of t. That means 2 into x of t. This is linearity or non-linearity, means we can take it as individually we can apply individual responses. That means we can take it as the system, the inputs are 2 input, that means x1 of t, and output is y1 of t. That is the linear combination. 2 it will be at a time will be applied, otherwise individual responses means the system will be applied first one x1 of t input and x2 of t. That means individual responses means individual, that is y1 of t equal to 2 into x1 of t, and we can individually, and next one the system will be applied to the x2 of t input and y2 of t. That means y2 of t equal to 2 into x2 of t. This is the individual responses or individual transformations. Individual responses, and we will combine. That means 2 inputs are we can apply the system for at a time, that is x1 of t, x2 of t, that means y2 of t, that means x1 of t, x2, that means the response is y3 of t. The individual response is we can take it as y1 of t, that means we can take it as y3 of t, that means the given system is 2 into x of t. That means overall response is 2 signals will be applied, then 2 into a x1 of t plus b into x2 of t. This is the individual response. This can be, these two responses are added, then the total that will be equal to that result, then it is called as linear system. We can take it as a into y1 of t plus b into y2 of t. That means a into y1 of t means 2x1 of t plus b into 2 into x2 of t. In this we take it as common 2, then a into x1 of t plus b into x1 of t plus b into 2 x2 of t. We take it as common, that is b into x2 of t. So that's why this can be individual response that can be equal to the total response, then it is called the given system is linear, otherwise the given system is non-linear system. Suppose we can take in place of x of t y of t equal to y of t equal to 2 into x square of t. 2 into x square of t. That means x square into 2 into x square of t. In this we take it as individual responses, that means y1 of t equal to a into, that means 2a into x1 square of t, y2 of t equal to 2 into b x2 square of t. These are the individual responses, that is a into y1 of t plus b into y2 of t, that will be equal to 2 can be taken common and a x1 square of t plus b plus b x2 square of t.
Now around 46 minutes, sir. 4 minutes you conclude.
Okay.
Next class we will.
Okay, sir. Okay, sir. And 2 into ax1 of t plus b into, this is the individual response and total response. That means output, that means the output is 2 into x square of t. That means the total, that means two signals will be at a time applied. That means x1 of t, x2 of t, that is output is y3 of t. That can be taken as 2 into square of something. That means two into a x1 of t plus two into a x1 of t plus b into x2 of t whole square. So this is the y3 of t, y3 of t. This is, that means this is not equal to the individual responses, because this is ax1 square of t plus b x2 square of t. In this, the term, that means ax1 square of t plus b x2 square of t, and another term, that means 2ab into x1 of t and x2 of t, another term will be coming from this equation. So that's why the given system is nonlinear system, that is a y1 of t plus b y2 of t is not equal to y3 of t. That means the individual responses does not equal to the total response. So that's why the given system is non-linear. And next, and remaining, that means time variant and time invariant. Time variant means in the input some t number of samples will be changed or delayed. In the output also the t number of samples will be delayed. Then it satisfies the condition, then it is called as time invariant, otherwise it is time variant. And another one is stable and non-stable. That means stable system means if you given an bounded input, it will gives bounded output. That means the system is said to be stable when the bounded output response is obtained for given bounded input signal. Then it satisfies the condition, then it is called as stable, otherwise it is unstable. So this session will be completed for the classification of system. Okay, thank you.